Hi, and welcome to this walkthrough of the parallelism functionality of Burr using the parallelism notebook found under examples parallelism. Now, we're going to assume that you know a little bit about Burr. If you don't, I invite you to go to the documentation. So if you just go to burr.dagworks.io, you can find how to get started there. I am going to actually be using Google Colab here, so I've already clicked and spun that up. You need to install the input, so I'm going to skip doing that here since I've already done it. And if you want to follow along with the exercise, you need to have an OpenAI key. At a high level, Burr's really good at modeling things as a graph or a flowchart, and we find that mental model thinking also lends itself very well to thinking about parallelism and recursion. And so in this notebook, we're going to be walking through four things. So one is how you don't have to use these constructs if you want to do parallelism. You can control it yourself. Some of what you can do with Burr's recursion to actually start to track things that are happening within a Burr action, since you can have Burr applications within Burr actions. And then I'm going to show the Burr's parallelism constructs, and then how one of them works, and then to give you some ideas and examples of how you can actually start to model more complex behavior more easily, and also then see everything with observability, which Burr provides out of the box. So I'm just going to run things here and kind of set things up. So we have some Jupyter magic here that we can load and run. And what this does is that it starts the Burr UI on Google Colab. But to expose things, we need to expose the port. So there's two ways you can do it. So if you run this, then and you click this link here, it will take you to where it's running. So here you can kind of see there isn't much set up yet because we actually haven't created a Burr application. The key here is you need to cut and paste this URL so we can go use it. In lieu of that, you can also just open up the port and have it as an iframe. And so this will populate as we go on. But just to make sure that the rest of the notebook works, we need to put in the URL of the running application, Burr UI that's running, and so I'm doing that here. And now we can continue. At a high level, in terms of how we're going to do things, we're going to assume what we're going to want to parallelize is assume we have some data and we want to parallelize that over different LLM models. So say some sort of prompt, parallelizing over models, and then we're going to join the result. Now, I'm going to first walk through three different ways to kind of do that. And so I am going to set up the input function or action is setting things into state, and then the last one will be joining these responses. So how do we run this kind of element of parallel? Well, one of the things that you can kind of do with Burr is just because Burr is unopinionated what you do within an action, you can do it kind of manually. So you can set up a thread pool executor with using normal Python code and just submit some sort of function in parallel, and it'll just work. So you'll get something like this. Now when here we go, we now have the Burr UI. When that Burr application kind of runs, we can see what went on. So if I turn on live here, we kind of see that it's running, and it's running processing a few things in parallel. With Burr, we can always see what the state was at since we can kind of check what the inputs, so we can always understand what went on. Let's see, this usually takes 20 seconds ish to run, so I'll pause here. Oh, there we go. It completed. And we can kind of close this, maximize it, make it a little bigger. But suffice to say, we ran things in parallel, right? Didn't get much introspection here as to kind of what went on, just because we're just doing stuff in the function. So the second approach is we can actually build a Burr sub application. In this Burr sub application, we have a single node, so it's very a basic thing, but we can actually wire through the context of this outer Burr application to this inner one. We can do the same thread pool executor. We're just submitting, running this kind of sub application. And so we have the same graph structure. We just kind of changed how you do query multiple models using the recursive constructs that Burr allows. And so when we so started this new application. We haven't start to run it here. If I click live, we can now then run it, right? And so this is where you can kind of see here that with the extra telemetry or app that we've kind of built and wiring it through, we can actually see what we spawned. So we spawned here 3 sub kind of processes or Burr applications, if you will, right? And because we have open telemetry turned on, we can then also go in and kind of see what went on. We can start to annotate things if we wanted to, right? And we can always go back to the parent. So so that's one of the things of Burr. If you really want to control the parallelism, you can, and then you can then wire through kind of tracking to then have things kind of show up in the UI. The third is using Burr's new parallel construct. This is a little more powerful in terms of just helps you think about a bit of the structure, right? In terms of specifically mapping and reducing. So before in here, like this is where you kind of did a little bit of everything. You mapped over it yourself, which you kind of did here, and then for each result, then you kind of aggregated things. With the new functionality, you now have a few kind of classes you can implement. And so I'm going to show map state. So specifically running the same action, which will be this thing here, running it over different inputs or different values of state. We could do something where we can map actions, which I'll show below, and then we could also do showing map state and actions. So if you really want to do the Cartesian product of things in state and actions, you can kind of do that as well. But specifically, the class is fairly straightforward. And the key things to note is we just need to yield a generator here that will return from values in state a particular singular value that then we can feed into this particular action for it to run. And then we then get a generator of results back that then we kind of reduce into some sort of value of state. And much like, because this is an action, so just like we kind of do reads and writes, we also need to specify for this parallel action what it reads and writes from the more macro level. So then we kind of construct our graph like we did before, and so here we actually have to instantiate the action as part of it. But when we build that, right, this graph looks pretty similar to what above. So restarting and kind of running a fresh application. When this runs, we will, if I click live, right, we can kind of see the same things happening here. And so this is effectively mirroring what we showed before in recursion, and actually with a new update, we'll actually be able to see in line here what's going on. And so stay tuned for that release. So what I've basically showed you is the equivalence of, I guess, 3 ways of doing things. And so those are pretty basic ways of using Burr to kind of do something. Like you see, this graph structure is pretty basic, or at least like what we want to kind of map over or parallelize is also fairly straightforward. If you want to build more complex Burr applications, right, there is obviously I want to say take a look at the docs. I haven't gone over and talked to anything about executors here, but we are adding more executors. So Ray, for example, is on the roadmap, but right now, say multi-processing, multi-threading are the 2 supported ones right now. If just to give you a sense of what potentially you could do that's more complex. So we have users who want to do, say, run medical diagnoses or hypotheses in parallel. Well, here we sketch out how you can kind of set that up with Burr. And so one of the ways that you can model it is if each one of our hypotheses could be a different graph of something that's structured very differently. Here in this example, they only differ by a single action, but it can give you a quick and easy way to potentially parallelize something and have a faster experience. And so the idea here is that we're going to create 2 graphs, one that would do some hypothesis 1, medical diagnosis, and the other one would run hypothesis 2. So say given some sort of transcript of input, right, figure out whether this hypothesis or this particular diagnosis is right or wrong here. these graphs are fairly static, right? So I'm just doing it pretty just to kind of show it, but these could be dynamically constructed, right? And so with we implement a class again to kind of do it. And so in this particular generator, we could actually dynamically create these graphs on the fly if we had more information about state, etc. But obviously, going to keep things pretty simple here, and just give you a sense of what you could do and where you could go. So with this particular map actions, we just got to return, rather than returning a generator of states, we're returning a generator of actions. We only have, one state here. You could provide the transcript in here, but here I'm just noting that this function doesn't really have to do quite so much. We then, doing a reduce step, so fairly similar to what it was before. And so the graph structure, again, nothing really has to change. We just have to, fill out the rest of the graph, right? And so in this one, it's pretty basic, but underneath in parallel, we can be running, n hypotheses and build something a bit more complex, right? And so similarly, we could do for, if you have URLs, you want to run some agents over, right? This is very easy then to model, right? We just need to, model whatever the agent is as a kind of runnable graph construct. So a graph with nodes and edges, but then a runnable graph just actually has a few extra things, meaning like what's the entry point and where should we finish. And then we can return that as the action and then map over different URLs that we kind of get, right? And so this is a fairly, I guess, straightforward way to kind of model this in Burr now, rather than you doing that yourself. You can now kind of depend on Burr to help. Lastly, you can actually do the Cartesian product between states and actions. And so where this could be useful is if you're trying to do some sort of experimentation, right? You want to do some hyperparameter tuning over maybe prompts, or maybe you want to actually build your own DSPY like kind of system, which you now, Burr gives you kind of the constructs to kind of do that in a way that is pretty, white box, so you can kind of, and not black boxy, so you can see everything that's going on. And so in terms of implementing that, right, it's not too different from what we had before. So rather than just returning a single action and states or vice versa, you now return two sets of generators, so one for actions and one for states. And so then what you could kind of do here is potentially, return different graph structures or different, parameterizations of a particular graph. And then in states, obviously, then you could run over different prompts and kind of run, therefore, then the Cartesian product will then all run in parallel, and then you obviously have a reduced step there to kind of aggregate it. And so at least in this particular setup, right, you could actually start to think about maybe something that auto optimizes the prompts given kind of for a particular graph, right? Run over different parameters and different things, and then loop around until you get some sort of good result. So just to finish, right? That's all I kind of wanted to go over. Thanks for spending time with this walkthrough. Hopefully, I gave you a bit of a sense of what you can do with Burr and what this kind of notebook can kind of teach you. If you want to know more, obviously there's some other cool features of Burr about test case creation. So say you're running this and you want to dig into something, right? It's easy to create a test fixture. Or if you want to, you saw something, you want to rerun it. Burr has time travel features, and then obviously you can also, with the Burr UI, start to annotate data, so you can actually curate things for evaluations. We're actively looking for contributors, so we'd love to have you aboard. If you like what you see or you have comments or thoughts, please drop by and in particular join Discord. Thank you.